Hello, my name is Gajeevan Singh Bopran. I'm from 3D Scanners UK. We are the master distributor of PolyWorks in the UK and Ireland. So in today's webinar, I'm going to be discussing some sheet metal inspection techniques. So we're going to be covering some tips and tricks for you to optimize your inspection process. And we're going to have a look at solving some issues that you may be having, such as the part being flexible, the thinness of the material, and feature extraction difficulty. The hardware we'll be using today is the Faro Quantum Max. This arm is equipped with a probe and is also equipped with a laser line scanner. This allows you to probe and scan your part at the same time. Also, today we have the addition of the Faro 8-axis. It effectively acts as a 8-axis of the arm, allowing you to spin the part in real time and inspect your parts quicker. This means you don't have to move your device or move the parts. Right, so let's get into actually scanning our part. So one of the issues raised was around part flexibility. With sheet metal and other thin material parts, you'll have the issue of part flexing if you did probe it, which can cause inaccurate measurements and is potentially an incorrect measurement. So with PolyWorks, we can actually do a boundary scan. And what this will do is pick up the sharp edge of the scan. Normally when you scan, you'll get a jaggedy edge, but when you use a boundary scan, you'll get a nice point cloud around the edge, which allows you to create features such as slots, circles, anything 2D or curve based really. So as you can see here, we have our scan with the boundary data, and we've also got our CAD. So first of all, what we're going to need to do is do a alignment. So initially we will click on the align tab here, and we will do a data to reference object. So this is essentially your best fit. So we will firstly go on here. It'll be a pre-alignment, and let's use the point pairs option. So we'll just start that. So we just get them both in line first. And essentially what we're trying to do here is pick the same points on each part. So it's a guidance for software to know where it is. So once we do that, then what we do is press align, and our parts are aligned by best fit. However, if we did want to do another alignment, for example, on sheet metal, you'll notice sometimes your data on a scanned part may not be the best, especially for holes. So if I show you this now on our boundary, we've got a nice clear defined edge. So for our customers out there who are using, say, sheet metal or carbon fiber, you may have these scenarios where you have a sharp edge which needs to be picked up. So as you can see here, what we're going to do is we're going to extract this feature. So firstly, we're going to create the features on our reference. So we're just going to make our reference visible again by middle mouse clicking. And we're going to do an alignment based on some features here. So firstly, we click on the Home tab. So if we have a look here, you'll now see all your feature creations moved up to here. This is new for 2024. So we're just going to click on the plane, and we're going to pick on our CAD model. So let's firstly do that here. And then, for example, we want a line between the holes and one of our holes to be a point, so a plane line point alignment. So what we're going to do is firstly click on circle and have it on pick on CAD. Next one over there. So now we've got a few features there. New in 2024, what we can also do is select our features, and we can create features directly from the tree. So for example, if I wanted to create a line from there we can. So we're just going to construct a line from object center points and even default it straight to what we wanted. So if I press create, you'll now see a line. So we've created our features on the CAD, however, we haven't extracted them. So I'm just going to show you some of the things you can now do with boundary. So if I make my data visible, you'll see we have our boundary data here. So let me just make the reference visible so it's a bit easier to see. You'll see there we've got our green points, which is a sharp edge, and we've got our surface data. So you can use both. So these haven't been measured yet. So what we're going to do is extract them. So we'll right click on plane one, go to our properties, and we'll go to a measurement tab and click on extract. So most of these settings will be okay in this instance. We don't need to change them. What we may change, however, is boundary exclusion, just to account for the bend radiuses within the part. So if we do change that to 2, for example, that will try and exclude the outside. And we're quite happy with all the settings here. So if I press apply, right click and extract measured, you'll now see a measured component is there. Now for the main part of what we're going to be talking about, say for example circles, we're going to extract them. So with curve based features such as a circle, we're going to need to do some things differently on extraction. So I'm just going to show you the scenario we have here first of all. So sometimes when you have surface data, your edges aren't great, and this can often lead to not the best measurements and may also affect your results. As you can see, it looks quite jaggedy. It's not the best radius there. So if I make my boundary scan visible again, you'll see now it's captured a nice edge of the sharp edge of the part. So for your sheet metal applications, this would be quite useful, as your parts may not really have any depth, so you can't really create a cylinder. So what do? You'd have to create a circle. So this really allows you to exploit PolyWorks to its best if you use these settings. So this is the boundary scan we scanned earlier. So I'm just going to make these visible, and I'm going to go highlight them both by pressing Control and clicking, and then I'm going to go into the properties. So in here, we're going to go to the second tab, which is the measurement tab. Then I'm going to go to extract, and you'll see we have a sub method here. And this sub method is trimmed, which we're going to use, which suits the scenario in. So this is essentially a scenario where you have sheet metal and your part is has no depth whatsoever. So we've got a few options here. So as our data object is a boundary, we'll use that. However, you can mix it up here. So you could have surface, boundary. It just changes the result however it extracts. So if we click on boundary here, it will only use the boundary data when we're creating that. So let's have a look on our left of our screen. Here we have the parameter visualization. Essentially all that's happening here is it tells you how it's fitting. So we don't actually need this super high. So we can say that is 4 millimeters, for example. We could probably say 1. It uses, 2, sorry. It essentially uses the boundary of the CAD feature that we've created, and it extracts a circle that way. So for constraining plane, we could extract a local plane, and these parameters are here. So it essentially extracts around it to create a local plane. However, all we're going to do is we use the plane feature that already exists. So that is plane 1. And we shouldn't really need to change any other settings here. So if we press apply, close, and extract measured, you'll see there we have a measured component there now. The floating part is the CAD, so that's not been perfectly aligned from the best fit, but that's what's to be expected. Also to note, if you did want to change the fit on these features, you could always go into properties and change your best fit min and max. It's up to you and your application. So you'll now see we've got a measured line, we've got a plane. So this essentially allows us to make a plane line point. So let's look at our tabs here again. So if we click on a line and then plane axis point. So we've got a plane, we've got an axis, and we've got a point in the form of one of the circles. So we're just going to click on that. Let's click on our source, which is plane one measured, and then our line as line measured. So essentially our source is a measured and our destination is a nominal. So by default, it captures it as the matching feature. So as you can see, we've done that for we've got a plane, we've got an axis. Now let's get a center point. So we're going to say that's circle one measured. So if we press confirm, we are now aligning plane axis center point. So you can see there the power of boundary scanning, for example. It does allow you to capture cleaner data in instances where you may struggle. So let's just have a look at the difference in alignment just to prove to you guys that's worked. So reference, you can see it's fitted to the plane there. If I activate best fit to reference there, you'll see the difference. So that has shown there is difference in alignment. In addition to the previous features I've shown you, I'm going to show you another feature which will be very useful for sheet metal parts. So firstly, we're going to click on the Home tab, and then we're going to go all the way across to comparison points, and we're going to click on the drop down, which will then show us trimmed edge points. So after we've clicked on trimmed edge points, we're going to go on the method using anchor, and then we'll be able to click on the part, on the CAD edges, to anchor our sheet metal points. So essentially what this is doing, it shows us a deviation of the sheet metal part on the edge and a back point going a bit further back just to show the surface data, how that's performing. So in order for this to work, you do need to make sure you have scan data in that specific area, otherwise it will not work. And it's a nice way to see how your sheet metal process has performed. So in processes such as machining and stamping where features have been made. Right, so what we're going to do now is we are going to probe a feature that we previously extracted on the last demonstration. So we've already aligned our part using the plane axis center point alignment. And what we're going to do now is just probe a circle just to show you an option that can be used on thin material. So in this instance, our part's actually quite rigid. I understand that sometimes you can have parts which are flexible, so this may not be suitable for them applications. But in an application where you got a part which is relatively rigid, you can still probe it. So in this instance, we will be using the thin material option. So as you can see here, we're just going to select the features on our CAD model. So all we're going to do is select our plane first, then our two circles, and we are going to quickly construct a line between the two circles. So that'll be from objects, as you would any other feature that we constructed. So once we've got that, we've got our features that we need for alignment. So we're firstly going to go into our properties and set our measurement parameters. So we're going to go on probe and then fix our number of points. This really just helps with our probing when we need to restrict the amount of points we want to take. Now, once we probe things such as circles, we're going to see the following options pop up. The thin material option allows you to enhance your probing on thin materials where it might be quite difficult to actually get the probe to be level with the surface that you're probing. It essentially improves the compensation that happens with the probe as you have given it a material thickness which is common in sheet metal. And set the material thickness to 1.5 millimeters. And we'll use a constraining plane from plane 1. And we're also going to fix the number of points we're using here. So if we press close, now what we're going to do is highlight all of our features and right click and probe. So once we click probe, we'll have to select the probing device from our list of probing devices. As you can see on our device tab on the top, we're going to select the faro arm that we've been using the rest of this demonstration, and we are going to connect to the device. So what we're going to do now is use the probe on the actual part. So the part isn't aligned yet, however, we're just probing where the device coordinates are. So you'll see after it's aligned, it will all snap together. So at the moment, we're just probing our plane. And we're just going to compensate. And then we're going to probe our circles using the parameters that we set earlier, using the 1.5 millimeter material thickness. So what we're going to do now is align via plane axis point. We're going to use plane, source plane or measured, and our destination is plane or nominal. And the same for the corresponding features with the axis and center point. We are now aligned our probe data with our CAD model. As you can see, there are some optimizations there for sheet metal probing, which can be used for your projects as you see fit. So as you can see, the probe is hovering above the part. That means we are aligned with the CAD in 3D space. So let's try another curve-based feature, such as a slot. So what we're going to do is first select the slot on our CAD model. So that is firstly clicking the slot on our home toolbar. And then we're going to pick on the CAD model. So as before, all we do is right click that, go onto our properties, and we are going to set our probing parameters. So we can go on method, probe, and the important one here is thin material. And we're just going to change that to 1.5. As said before, this is how we can optimize our sheet metal probing parameters. So what we're going to do here is also have 5 points per arc on our slot and have a constraining plane, as we don't have a constraining plane already probed, so we'll need to probe around the feature. If we press apply to that, we can now probe measured our slot. And as you can see, it's as easy as that. Just as we did before, we're just going to probe that feature. So you can see our probe knows where we are, and now PolyWorks will automatically zoom in on the feature. So we're just going to probe around the feature first. And now compensate, and then we'll probe each side of the arc. So as you can see there, we have our feature which is measured. And that is how easy it is to probe on sheet metal. And that is a few of the settings that you can optimize there. As you can see, it's quite a big deviation there, but as this is a demo part and the alignment we've used, this may be the reasons. Thanks for joining our webinar today. If you do have any comments or queries, please drop them in the comment section, and be sure to subscribe to our YouTube channel for more PolyWorks content.